Hello everyone. Today I'll be teaching you DH parameter of Stanford Manipulator. That is, we'll find out the forward kinematics of a Stanford Manipulator. So what is a Stanford Manipulator? Stanford Manipulator is a manipulator whose configuration is RRP. That is, its first joint has a revolute joint, the second one also has a revolute joint, and the third one has a prismatic joint. That is what I have indicated here. That is theta 1 for the first joint, theta 2 for the second joint, and D3 for the third joint, which is its prismatic joint. Now let's look at the forward kinematics or the DH convention. For the first link, we see that we don't have a value of DI. That is because we don't have any offset value in that direction. AI value is 0 for this case because we haven't specified anything. If it's specified in the question that you can assume the AI value to be X, then you can go ahead and put its value. But if it's not, you can go ahead and put it as 0. That's what I've done over here. For the value of theta I, we know that it's a revolute joint and we have its value specified as theta 1. Since theta 1 is a variable, since it's a revolute joint, we will specify it with a star mark. Now, very important thing about this manipulator is that its alpha I value, that is its value of link twist. If we look at the first link with respect to the 0th link, we find out that Z1 has rotated 90 degree with respect to Z0. This rotation has taken place clockwise. So this makes our alpha I value as minus 90 since it is clockwise. If it was anti-clockwise, we would define it as plus 90. Let's look at to the second link now. Yes. From the book which I have referred, John Craig's book, in the book the question had specified the value of DI, that is the link offset value, as D2, which is supposed to be a constant over here and it's not a joint specification. So here I've taken it as a D2 which is constant. Again, the link length for the manipulator for the joint 2 is 0. Now let's look at the value of alpha, that is the link twist. As I mentioned above, that if the value of Z2, that is the next frame with respect to the original frame, is rotated, we'll see how much has it rotated. If it's rotated clockwise, it will be plus. If it's rotated anti-clockwise, it will be negative. So here, the rotation of Z2 with respect to Z1 is in anti-clockwise direction, which will make our alpha value as positive 90. Just like the link 1, the value of theta I, since it's a revolute joint and it's a variable value, will specify it as theta 2 with a star mark. Every time something is a variable, you mark it as star mark. That is the rule. If it's constant, then you'll go ahead and put it as D2, D1, AI, A2. Okay. So now let's look at the link 3. In link 3, as I mentioned above, that if it's variable and it's a prismatic joint, so we have it as D3 with a star mark since it's a variable value. Again, our link length is 0. Our rotation hasn't taken place. And so we say that it isn't rotated and it's not going to rotate. Since it doesn't have a revolute joint over here, and we say alpha 3 is 0. Theta 3 is again 0 with the same reason. There is no rotation of the joint. You can go ahead and put a wrist at it and find its forward kinematics, but this thing is enough as a whole to find out the rotation and the forward kinematics of the manipulator. Once you get all the values of D1, D2, D3, A1, A2, A3, alpha 1, alpha 2, alpha 3 and theta 1, theta 2, theta 3, we'll go ahead and find out its homogeneous transformations. So let's look at it now. When we say we'll find out the value of A1, we'll go ahead and put it as values from A1, that is small a1, alpha 1, theta 1 and d1. We'll put it into the value of the DH parameter, the main matrix which we had found. You'll go ahead and do it on your own and you'll come up to something like this. That is cos theta 1, sin theta 1 over here. Similarly, if you go ahead and find out the values for link 2 and link 3, that is homogeneous transformation according to link 1, homogeneous transformation with respect to link 3. You'll come up to something like this, 2 matrix. Now, as we have seen in the earlier videos, if you want to find out T matrix with respect to the 0th frame for the 3rd frame, we'll do it as A1, A2, A3. Why so? I've already explained to you. Please go back and understand that concept really well. It's really important. So we'll go ahead and multiply all the 3 matrices and we'll come up to something like this matrix. This matrix is your DH convention for the Stanford manipulator. To find out the forward kinematics with respect to X, Y and Z, this 4th column will specify all the values. That is, the first row and the 4th column first element will specify the value of X. The second row's 4th column's element will be the value of Y. And similarly, this will be the value of Z. If you have any queries regarding to robotics, mathematical approach, please comment below or you can mail us at our email ID. Please subscribe if you liked it. Thank you. Robometrics.